Hello students, welcome to my channel. In this video we are going to study about hydrostatic pressure. Okay, here we will understand why pressure increases with depth. Okay, so students, let's start. So here, see, why does this matter? That is, why does this hydrostatic pressure matters in engineering? So here, see, dams hold back enormous water pressure. For that reason, here hydrostatic pressure is important. Okay, so further, as you can see here, this is a dam, and and behind this there is enormous water, and this water exerts some pressure on this dam structure or dam civil structure. Okay, so here this hydrostatic pressure plays an important role. Okay, so further, see, submarine hulls withstand pressure as they dive. Okay, this submarine outer body, okay, this outer body called as hulls, okay, that experiences pressure due to water when they travels inside the water, okay, or inside the sea. Okay, as they go downwards, the pressure on the hulls or submarine bodies experiences more pressure. Okay, so further, now see here, divers feel increased pressure with depth. Okay, so here, see, when divers go downwards with more downwards, as they move downward in water, they experiences more pressure. Okay, so here in these all cases and some other cases also, this hydrostatic pressure plays an very important role. Okay, so here, see, further now, understanding pressure, let's see here, this is a one of the diagram. Suppose this is a swimming pool. Inside the swimming pool, Raj and Amol is diving. Okay, they are doing swimming. Okay, so here, as you can see here it is a depth in meters, and here this is the depth in here this is the pressure in pascals. This is suppose this is water body, or you can call this at sea. Okay, so here, see, as Raj is at this position in between these 2 meters and 4 meters, it experiences the pressure between 20,000 to 40,000 pascals. Okay, and as you can see here, Amol is at the height 8 meters, and so he experiences 80,000 pascal pressure. Okay, so from this we can understood that here, as the depth increases, the pressure increases. Okay, so here, see, what is pressure? Pressure is the formula of the pressure is force upon area. Okay, so here, see, in fluids, this force comes from the fluid's weight above a point. Suppose this is a point where there is a Raj. At this point, the above this Raj, there is some weight of the fluid, in this case the weight of the water. This weight is called, from this weight force comes. Okay, so further, see, deeper, more weight, more pressure. Okay, as I told you, as we move downwards, goes more deeper, the pressure will increase more. That is, depth is directly proportional to the pressure. Okay, so further, see here, let's see now deriving pressure in a fluid. Suppose this is a container and of having diameter d, and area of this container will be pi by 4 into d square. Okay, and here, see, suppose this is a point, and at that point we need to calculate here pressure, and this point is here at height h from the liquid top level, as you can see here. So further, see here, consider a vertical fluid column of height h and cross-sectional area a is equal to pi by 4 into d square. Okay, so further, see, force is equal to weight is equal to mass into acceleration due to gravity, that is m into g. So further, see here, mass m is equal to weight upon g. From this we derived m is equal to weight upon G. Okay, so further see here, density is equal to rho is equal to mass upon volume. Okay, so now let's simplify it again. We will put now the value of m in this equation. Rho is equal to mass upon volume. So here from that we get here rho is equal to weight upon GHA. Okay, now let's see here, weight of fluid we will get here. We will move this term GHA in the leftward side. From that we will get here now weight of fluid is equal to rho GHA. Okay, so further see here, pressure at depth is equal to weight upon area, that is as we have seen earlier. Okay, so see here, pressure at depth is weight upon area. So now let's further simplify it. We will put the value of weight in this pressure equation. From that we will get here now pressure is equal to rho GH. Area and area will get cancelled. Okay, now so here pressure is equal to rho GH. This is the equation for pressure. So further see here, now hydrostatic pressure formula, as we have seen earlier, we have derived it, that is pressure is equal to rho GH. So now here see, at this is so suppose a water body, inside that a person is diving, as you can see here, and its head is at 2.1 meter and its leg is at 1.2 meters. As we go deeper, as you can see here, pressure distribution, pressure is increasing. Okay, so now let's see here, P is equal to rho GH, pressure is equal to rho GH. So here rho is the fluid density, G is equal to acceleration due to gravity, H is the depth from the surface of water or fluid. Okay, so now further see here, absolute versus gauge pressure. So here gauge pressure is equal to rho GH in our case, and so that absolute pressure will be equal to atmospheric pressure plus gauge pressure, that is rho GH. Okay, so further see here now, as let's see the example. As you can see here, this is the as the depth of water or height of water column increases, the pressure increases linearly, as you can see from the graph. So further now let's see here the example, pressure at 5 meter depth. Okay, so see here, rho is equal to 1000 kg per meter cube, 1000 density of water is equal to 1000 kg per meter cube, G is equal to G, that is acceleration due to gravity, is equal to 9.81 meter per second square, and H is the height, that is depth 5 meter. Okay, so let's see, P is equal to rho GH formula we are using here and putting the values. From that we will get the value here 49.05 kilopascal. Okay, so pressure increases linearly with depth, as you can see from the graph. Okay, let's see further now applications of hydrostatic pressure. So here dam design, thicker base. For dam design we need the hydrostatic pressure. So further see submarine and ship hulls. For that also we need the hydrostatic pressure. Further the pressure measurement in tanks and water columns. For that also we need the hydrostatic pressure. So further see here now hydraulic systems. Okay, so let's see summary key takeaways from this whole study. So here see, pressure increases linearly with depth. Okay, formula of pressure is equal to rho GH. Important, it is important, hydrostatic pressure is important in engineering, structures and systems. Okay, so students, in this video we have understood about hydrostatic pressure. Thank you students for watching this video. Like, share and comment for this video and subscribe my channel. Thank you.